Hey guys, welcome back to the channel Campus Coders. Today we will see few more questions on binary search. Okay, so this question they are told like they have given a strictly increasing array and a positive integer k. We need to find the kth positive integer that is missing from the vector. Okay, so let's say they are given this vector an array and then they will give a value k. Let's say it's 3. Okay, we need to find the kth missing positive integer from this vector. Okay, so what we can do is in this vector, let's say if there is no missing elements, okay. So if there is no missing element, the array would be something like 1, 2, 3, 4, 5, right? So for using this, what we can say is uh, we will check how what are the missing indexes in each and every index, okay, missing elements. So in index 0, okay, if you see here in index 0, what are the elements missing? Only one element, 1 is missing. Similarly in index 1, if you see, still in the only element 1 is missing. If you go to index 2, okay, in index 2, this index, if you see, still one in only one element 1 is missing. If you go to index 3, you can see index 3 is this, element 1 is missing, and then what else are missing? The element 5 is also missing, right? 5 is missing, and then 6 is also missing. So there are three elements missing within index 3. If you go to index 4, then it will be these all these 3 plus 8, 9, and then 10. Okay, so there are 6 elements missing within index 4. So based on these observations, if you see how many number of indexes are missing in each and in every index, we can come up to a formula that is number of missing numbers up to index I is vector of I minus I plus 1. Okay, if you let's say take the example of index 3 here. So what is the element in index 3? That is 7. So 7 minus 3 plus 1, 4. That would be 3, right? So there are three elements missing in this array. Right? So you can say how we got this formula, because if there is no missing elements, okay. So the at that index place there will be index plus one element, right? Here, if the in the third index the element is 4, because it's strictly increasing with starting from 1, so index is 4. So there will be numbers from 1 to 4, but there is 7 here. So what we can say is there are three more elements that's there between these two arrays, such that that's why we got 7 in the index 3 here, right? So we can just directly say 7 minus 4, 3. 3 is the number of missing elements. Similarly here 11 minus 5, 6. So 6 elements are missing here. So we can subtract these two and then get the number of missing elements. So that's one thing which we have found using observation. And one more thing is we need to find all the adjacent um missing elements, right? Because we need kth positive integer that's missing. We need not to check every each and every places how many elements are missing. We need kth missing element. So what we can do is we need to find a pointer that's closest to the neighbor. So let's say we need missing third missing element here, right? So third missing element here would be 1568, right? So we need a pointer that is less than this required missing value, and then it should be nearest as well, right? So the pointer high pointer will be the one that would be closest to the neighbor, and that is smaller than the kth missing element. So number of missing elements would be vector I minus I plus 1. Okay, we are just taking a pointer, instead using a binary search we will have small pointer and then high pointer. So we are taking high pointer because small pointer will be obviously so far from the required bud. So high pointer would be the one which is closest to the neighbor, and which is the one we are changing. So here we will have vector high pointer. So let's say at one index we are taking, and then we are finding the how many missing elements are there in that index. Okay, we need kth missing element. Okay, so that means we have, at this index for now we have m missing elements, we need k missing elements. So how many more do we need to get reach k? That is k minus m, right? K minus m more elements is necessary to reach m to k. So that's what we are doing here. We have missing this many missing numbers in that index. Okay, this many missing index in that index, we need k index as our that's our priority to find. So how many more index do we need to get? K minus this much index, this much number of numbers are missing, right? So this is the how many more missing elements we need to find. Okay, and using this we can find the kth missing element. So kth missing element will be nothing but the element plus how many more missing elements are necessary, right? So we can just add that element. Element is nothing but the vector at pointer height plus how many more elements are missing. If we add this and then do the simplification, we will get this as the formula k plus I plus 1. Okay, so we can just use this in our binary search idea. So we have low pointer and then high pointer. We will calculate the mid, and then the missing element would be, we are going to find the missing element in that point in that index. And then if that missing element is less than the required k, we are going to increment the low pointer. If it is not so, then we are going to decrement the high pointer, and then we are going to return the whatever calculation we did earlier, that one we are going to return. So that's it for this question.
The next question, they are given an array which represents the distance between two stalls. Okay, so let's say zero at zeroth position there is one stall, at third position there is one stall, fourth position there is one stall. So it represents the distance. Okay, so we need to find the maximum possible minimum distance, and then we are going to assign like k cows in those stalls. Okay, in the here there are six stalls. We need to assign four cows in those stalls such that the distance between the cows is maximum between them. Okay, so let's say see how this works actually. So first thing we need to do is we need to sort the array, because we need to see what is the distance between each stalls, right? So we will sort the arrays like this. Zero, this is like, let's say this is another example of array. It's 0, 1, 2, 4, 8, 9. Okay, for this array, let's say this is given in some order. We are going to sort it first. Okay, so we need to assign three cows in this. For this array we are going to assign three cows. So for first we will assign the first cow in the first array. Okay, in the first part, let's say 0 is not there. Okay, Uh, we will assign first cow in the first stall, and then we will check where we can assign the second cow. Okay, we will say assign the second cow in the second stall. The distance between those two will be 1. Okay, the third cow will be assigned in the third stall, which is at distance 4 from the first, which is at the distance 4. It means the distance between C3 and C2 will be 2, right? And C3 and C1 will be 1. So here the in this way, we will find the minimum distance would be 1 in this case. Okay. If you see in this case, when we are assigning C1 in 1 and C2 in 4, the minimum distance will be 3, and then here it will be 4. The total minimum distance will be 3. If we assign in this way, again the minimum distance will be 3. So if you do it take like a trial and error method, we can say minimum distance possible would be 3 only. So for this the answer would be 3, right? The similar way we need to do it for whatever. So here, in this way, we for whatever cases they give, we are going to find the minimum distance for whatever the number of cows they give for like. So we will see what is the possible way to do this. So as I told earlier, we are there asked us to find the maximum possible minimum distance. So using these keywords, we can say this is a question related to binary search. We need to do using binary search algorithms. So the first step to find use binary search algorithm would be to find the answer space, right? The range of space where the answer could possibly lie. So that would be, let's say, the minimum distance, and there would be the minimum possible answer, and then the maximum distance between two stars would be the maximum possible answer. So we can, from whatever the answer array they give, we can traverse through this part of range and then check which would be the possible answer, right? Let's say in this case itself, okay, the minimum possible answer would be 1. The math as that is 2 minus 1 1. The maximum possible answer would be 9 minus 1 8. So answer might lie between 1 and 8. We can do the binary search algorithm between 1 and 8, find the midpoint. Here it will be 9 by 2 4. So we can see if 4 would be the minimum distance, and then based on that we can go through, right? So first step would be simple, like, okay, the first step would be to find the first, sort the array, and then have a low pointer and then high pointer. It would be the last step, okay. And then we are going to do the binary search. We are finding the midterm, and then we are going to check if that midterm is actually it can be actually an answer for our question or not, like whether it would be the minimum distance or not. So here we are going to call a function, okay, can we place, in brackets stars mid and k, okay. So what are we going to do here is we are going to pass these as the parameters, and then we are going to the uh, main functioning of this problem, okay. What we are going to do is we are going to have two uh, variables, one for count cows, like whether all the cows have been placed or not. We are going to have keep a track of that, and then we are going to keep a track of the last placed cow, okay. So that we can in the next in every iteration we can check if the distance is actually greater than the given midterm or not. So first, initially we will position have the position of first curve in the first element, and then we are going to iterate in the remaining array, and then whenever the distance between the previous curve and then the present iteration is greater than the mid element, or the distance which we are finding, if it is correct or not, na. So we are going to check if that is greater or not. If it is greater, then we are going to place that curve. That means we are incrementing the curve's value, and then we are changing the last position to the current iteration position, right? Let's say here we will position the first curve, okay, and then we are going to iterate this part of array, okay. While iterating, let's say we are going to this to a step, okay. For now the mid element is 4, right? Where let's say from 1 to 9 here in the binary search, we are going to have the mid element as 9 plus 1 10, that is 5. Here the fifth portion, it can be 4, right? Just by looking at this we can say it's 4. So we will check if the distance is greater than 4 or not. In this iteration 2, it will be 2 minus the last position cow is 1. So 2 minus 1 1, which is not greater than 4. So we are not going to do anything. We will move to next element. Here it is 4. 4 minus 1, it is 3. 3 is not greater than 4. We are going to 8. 8 minus 1, 7. 7 is greater than or equal to 4. So what we are going to do is we are going to place the second cow in this element. Okay. We are going to say place the second cow here. That means the last pointer would move on to here now. Okay. And then we have placed two cows right now. First cow will be here. Second cow will be here. Okay. And then we need to place three cows in total, right? We need to place three cows in total. So we are going to have the next iteration. Next iteration should be 9. 9 is greater than 9 minus 8 is 1, that which is not greater than distance. Okay. And then there is no more things to go. So this is not possible answer, like 4 is not the possible answer, so we are going to return false. Okay, so if at all in an iteration, let's say it is like we have placed all those three curves. Okay, after three curves we need to come out of the iteration, right? So we are having another condition that if curves is the count is equal to the required number of curves, we are going to return true. Okay, that means the current distance which we have taken is can be a possible answer, right? So here, if it is like a possible answer, then we will then it means if the minimum element, the mid element which you have taken has been like a possible answer, then it means we need there will be some, there can be a possibility that there will be some other elements that is greater than 4 which can also be the an answer, right? Because we need to find the maximum possible minimum distance, so we are incrementing the low pointer. Okay, so that we will have some other mid value which is greater than the current value. Okay, if it is false, then we are going to decrease the high pointer to mid minus 1, so that we will have some other mid value which is less than 4 which can be a possibility of the answer. So in this way we are going to do, and then we are going to return the high pointer. So in this given question, they are given an array which depicts the books. Okay, the number of pages in each book. Okay, in this array, there are like 5 books, and first book contains 25 pages, second book contains 46 pages. In that way, they are given the number of pages in each books, and they are given a number m which depicts the number of students. So we need to distribute these 5 books among these four students such that each student gets at least one book, and then one book will be assigned to only one student, not like there is no chance that two students can share a book. So in that way we should not do, and then we need to find the minimum possible maximum number of pages assigned to a student. Okay, so let's say if in this case here there are like 4 students, right? So if 4 students, 5 books, that means there is a possibility that one student gets two books, right? And also there is one more condition that each book should be allocated in the contiguous manner. Like first book should be assigned to first student. There is no possibility that the first student can get the last book. So that kind of things is not possible. So whatever the order they have given, we need to maintain that order. So one thing we can say is we cannot sort the array like how we did for minimum the cows question, right? So we need to keep that in mind. So let's say in this position when we are uh, distributing 5 books among 4 students, then it means the last any one student will be getting 2 books, right? In one case the last student gets 2 books, it means here the maximum number of pages the student can receive will be this part, right? The last student, that will be 73. If in case the third student gets the 2 books, okay, the maximum number of pages will be in this case will be 77. The same way we will find all these possible cases, and we can see the minimum of this maximum number of pages would be 71, and which is our answer as well, right? So in this way we need to find. So as said, we are going to find the minimum possible maximum number of pages. It means binary search. Then we are going to find the answer range under which the answer can lie. Okay, so we will find the least possible case. That would be, let's say there are like 5 books and then 5 students, it means each student will be getting one book. So the minimum possible answer would be the minimum of the array, right? When we find get the minimum of the array, like sorry, the maximum element, because the maximum number of pages student can receive would be the is what we are finding, and then we are finding the minimum of those maximums. So the maximum element in the array would be the minimum possible answer, right? So that will be minimum possible answer. The other one will be there are like 5 books and then only one student is there, that means the only one student will be getting all those 5 books. So the he will be getting the sum of all pages, that is the number of pages he will be getting. So that is the worst case, so that will be the highest possible answer as well. So the minimum possible answer will be maximum of the element, highest possible answer will be the sum of the array. some of the pages, right, given in that array. So we will keep these two as the answer range, and we are going to do the binary search in this. We are going to find the mid element, and then what we are going to do is we are going to check like how many students would be possible to split this mid element. Okay, that we are going to find. So we are going to call a function, right? So we are going to count the number of students such that the minimum number of possible maximum number of pages is the mid element which we are checking now in each iteration, right? So if it is like greater than the number of students they gave, okay, let's say in one iteration, okay, I will say in an example. Let's say there is 1 and 9. The 1 and 9, the minimum element would be, sorry, the mid element would be 5. Okay, now we are going to check if you in 5, like that means the if the answer is 5, okay, the minimum possible maximum element is 5. We are going to find how many students it will take so that the answer would be 5. Let's say it is like 3 students, but the question is asked that we need to distribute to 2 students only. So of course this is not the possible answer, right? Because we need to distribute to 2 students, but when we take 5 as the answer, the possible number of students would be 3. So 3 is greater than 2. Then what we need to find is what we need to do is we need to increase by the low pointer so that we will get some other higher value of mid element such that we will have the number of students as 2. Okay, so just like how we did for cows question, we are going to increment the low pointer in that case. If not, we are going to decrement the high pointer in this case. Okay, and we are going to return the low pointer. So we will see what is done in this count students function. So we are going to have a students variable which keeps track of number of students, and then the pages, maximum pages that the student gets, that we are going to track. And then we are going to traverse through the array, and then whenever we are going to do the prefix some kind of thing, we are going to add each and every element, and then we are going to check if it is less than or equal to pages. If it is less than, then we are going to add it as such to the pages student. If at all it exceeds the pages, okay, then it means we need to move on to the next student, right? So we are incrementing the student's account, and then we are assigning the pages student to ARR of I. Okay, so in that way we are going to do, and then after doing all those things, we are going to return the students, number of students, such that the minimum possible maximum number of pages would be this mid element which we are passing as a parameter. And then this student number of this count of students will be checked here in the binary search thing, and then we are going to return the answer. Okay, this is like more or less similar to the question which we did the previous one.
That's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.